What's up, guys? It's Mr. Bringle, and today we're going to be talking about work and simple machines. So, work is a transfer of energy that occurs when a force makes an object move. So, it is a force that's applied to an object over some distance, and that ends up being the equation for work is force times distance. So, for work to occur, something has to move, and it's always going to be in the same direction that the force was applied. So, for instance, if I pick this pen up off of the desk, I'm applying a force upwards, right? And the pen moves upwards. Uh, so work is also measured in joules. And I say also because we've been talking about energy, right? We've been talking about energy, and energy is measured in joules, and so is work. Okay. And then another term, power. Power is the rate at which work is done. So power, the equation for that ends up being the work divided by the time that it took to complete that work. Okay. So the rate at which work is done. Okay. So things that help us do work, right, would be machines. They make work easier. And you might be thinking machines like a mechanical machine, but as we're going to learn here, machine in physics terms can be very simple, like, for instance, a seesaw or a hammer, right? These can be considered physics machines that help make work easier. Okay, so and usually that's done by helping us increase the amount of force that's acting on the whatever object we're trying to do work on, right? So, for instance, you could use a pulley. The purpose of a pulley is for us to put in work by pulling on it, but it ends up adding additional force and allows us to pick up things that are larger or heavier than what we normally would. So there's two forces involved when a machine does work. You've got your input force and your output force. And if you've ever used a hammer to pull out a nail, then you've experienced this. And so you use the backside of the hammer to pull the nail out, right? But what you have to do is you have to wedge that thing in there, and you start pulling the hammer, right? Well, then, so that's your input force. And then the hammer applies a force to the nail to pick it up and get it out of where, the wood that you had it in or whatever it's in, right? And so if you just tried to pick up that nail by yourself, it's going to be really hard to get it out there. But by using the hammer and rocking it, you're able to get that nail out of there. And that's because the hammer is helping you do the work. Okay, so your input force creates an output force that the hammer uses to get the nail out. Now, mechanical advantage is the ratio of output to input force. So ideally, a good machine will have a mechanical advantage that has whatever the input force is, the output force is larger, right? To help us get work done. And the efficiency of this would be how much work you put in versus how much useful output work is given by the machine. So obviously we want to be efficient, and you don't want a whole lot of friction involved, because friction will reduce efficiency. So if you can minimize the friction, your efficiency will be higher. Okay, so a couple different types of machines. There's simple machines and compound machines. The simple machine would be doing work with just one movement. So like the hammer, you pull, it does the work, right? You pull on the hammer, it lifts the nail up. So that would be a simple machine. A compound machine is going to have two or more simple machines that operate together. Okay, so a couple examples here of machines. You've got levers. So that would have been like the hammer that we just looked at, but there's going to be a fixed point that's balanced on something. So a fulcrum, your elbow represents a fulcrum. The point on the scissors right here where they're attached, the two sides are attached. Even when you use a broom, right, you're holding it in one place and you're moving it back and forth, right? That fulcrum is that fixed point where it moves on, right? The hammer, the way that you rocked it, it's rocking on that single point there. Okay, wedges. So wedges have two inclined planes, and things like knives and axes would be considered wedges, right? They have an inclined plane on either side here, so it creates that sharp edge. But there's other things too, like you see a lot of tools down here. The nail, the beginning of the nail here, the point of the nail is another example. Wheel and axle, pretty self-explanatory. You've got a bike, any sort of steering wheel, like a naval ship wheel, the Ferris wheel, door handles, all those things. Pulleys, which I mentioned earlier, you use wheels and ropes to raise and lower objects, and you can create very complex pulley systems where your input force has to be very minimal. You just have to apply it for a long distance, and then you can lift very heavy objects. So the idea with a pulley is that if I decrease the amount of force that I have to put in, okay, so let's say I'm trying to lift like a 50 Newton box, right? But I can't do it on my own. So I set up a pulley system. What I can do is I can use half the force, but I have to pull the rope twice the distance. So it's less force that I have to put in. It's not as difficult for me to lift the box, but I have to pull it for a longer period of time to get it to raise up the same distance than if I just picked it up. Okay, so if you added an extra pulley, if you made it a double pulley system, then it would reduce the force even more, and then you'd have to pull it even further. But again, it would just be easier. And then screws are technically an inclined plane that are wrapped around, right? So some object. So when you look at like the top of a can or bolts and a nut, drill bits, these are just inclined planes that are wrapped around in a spiral. And then an inclined plane would be what you would think. It's like a ramp. Okay, so the ramp off the end of the truck here, a slide, the ramp, the handicap ramps. Okay, these are all inclined planes. Okay, so you will be using the last few slides here for your, when we start talking about the different types of machines, these slides will be used for your assignment today. The first 6 slides are used for your notes. Let me know if you have any questions.